Hi, welcome to Parametric House. In this tutorial I want to show you how you can convert two curves into a surface, but as you can see here, this is going to be a more advanced loft than a simple loft, because if we loft these two together, if I say loft and select these two curves and hit OK, this is going to be the loft. But now, as you can see here, what we're going to control in this surface is going to be some tangents here, and this will give us more control over the shape. So here you can see that it's going to have a smooth loft effect by just defining two curves. Okay, let me turn off the algorithm and explain how it goes. First of all, what we have here is they are two curves, obviously. The bottom and the top doesn't really matter, and because we want to make this even work for polylines, so for example, if I make this as a polyline, we want to get results, so it's going to be something like this, as you can see here. That's why I have actually rebuilt those curves to get good results even if we have a polyline. So let's go back to curve, because we wanted to explain what's happening here. And for the rebuilding, we can go to the curve utility, and here you can see that we have the rebuild curve component. You just give the curve to the curve input. The D is the degree. I have given the degree 3 because we want NURBS, and this is just a count because I want exact results. I have given 200 to this. You can even change that to more numbers if you want more precision. So this is just like a precision thing. If I bake it, you can see that it's going to rebuild the curve here. This is the main curve we have, and this is the rebuild curve. It's going to give you more control points, so this is going to be useful especially for polylines. Okay, after we have rebuilt the curves, we have to loft them together. Surface freeform loft. So we just give that to the loft, and you can see that's going to be something like this. Okay, for the loft option, what I want to do here is to work with the adjust. So I'm going to use a toggle, TOG, Boolean toggle, and give it to the adjust. And let me explain this with two curves rotated. So for example, if I have a copy of this ellipse, make it a little bit smaller, and let's rotate this a little bit, something like 180 degrees, and bring it a little bit up. Okay, and let's go select them. Okay, if I put this adjust to false, you can see that this is going to twist the output, but because we wanted to have minimum rotation, we can put this to true. And as you can see here, even if the direction, we can select the curves and say DIR, which is going to give you the seams. Here you can see that the seam is here for this curve, and the seam for the second curve is here. So it's like 180 degrees rotated, but when you adjust it, it's going to fix that easily for you. So just play with this with different projects if you want to adjust the seam. And now that we have the loft, what we want to do here is really simple. We just want to create a Bezier span. Let's also decrease the number so you can see the spans. And as you can see here, we're going to define a tangent for the start and the end. I'm just changing this so you can see the tangent here. And because I wanted to make it as simple as possible, we just want to use the tangent C. Okay, so how can we do that? We can simply go to the curve, spline, and use this isocurve component. You can see it here. We can reparameterize it, so it's going to be from 0. Okay, for this one, I think it's here. It's going to be 0 to 1 for the U direction. And let's go for blue. And 0 to 1 for the V direction, right? So these are the two directions. Because we want to extract it, so we reparameterize it. For the UV, we can use a vector, a point. You can see we have a construct point, And obviously we just want to use the XY. The Z is not going to be anything, so I'm going to just say it's not available. And the X is going to be U, and the Y is going to be V. That's when you have a NURB surface and reparameterize it, it's going to be between 0 and 1. So U for here is 0. Let me give a number slider between 0 and 1 so you can see what it means here. I'm going to give it to the V and flatten it because I want to show you what's happening here, okay? When I change this number, you can see that I'm moving on the surface in the U direction, which is not really that important because we want these lines to make the ribs, okay, for the ribs. So we're not going to change the U direction. We want to create a series of V's between 0 and 1. And for that, we can use a set, a range between, when you put the range on the canvas, you can see it's between 0 and 1, obviously, and then you just have to give it a count for the division. So that when you connect that to the V, and you can simply flatten the U and the V, this is going to be the V, which we don't want. The U is actually what we need, which is controllable by the number of we defined here on the range. We can even change that to 4. Maybe we just want to put 4 ribs here, and if you increase it, it's going to give you more ribs. Okay, now that we have the lines, we can simply use the curve endpoints to get the start and the end, as you can see here, and use them as the base for the Bezier span. So you can go to the curve, use the spline, and here we have the Bezier span, which I really love. And the reason here is that you just have to give the start and the end for the curve. Okay, so A and B are going to be the start and the end, as you can see here. And then you have to just define a tangent for the start and the end. And because I wanted to make this as simple as possible, because we can give different vectors here, maybe you just wanted to flat this here and make it like this. And it's going to be complicated, but we wanted to make this lesson for a Bezier span, as you can see here. What I have done here is I have given a Z, unit Z vector to both the tangent start and the end, and then you just have to give it a multiplication. Remember that you can give it a negative or positive. So if you give it a positive, it's obviously going to be upwards, and then if you give it a negative, it's going to go downwards, right? So here you can see that this is going to be, I think it's going to be from the start here. You can see that it's moving up and down in the Z direction, and then we will have here another one. If I put it to 0, you can see that the tangent here is not going to be important, it's just going to connect it at the end. But if we increase it, it's going to go up. Okay, so this is like the simplified way of making a parametric Bezier span. And then we just have to fix something I'm going to explain. If I loft these together, you can see that the loft is going to give you an error. So I'm going to explain what happened here. So if I bake these, and let me select them, bring them here. And the reason here is that one of the curves are duplicates. So I'm just showing you, I don't know where the seam is, so I'm just selecting here, okay. Here you can see that because of the duplicate Bezier span, we have an error for the loft, okay. So we just have to delete the first and the last one, that's like the duplicates we have. And what I have done here is use the set sequence call index and give it to the curves. I reversed the list, so the last one. So for example, if I wanted to, how I debugged this was like this. I went on a curve middle, and then I used, this tool is really great, point order. I watched the order and I saw that it's okay because we actually want to make it a loop. So the order was not the problem. The problem was the points list. I baked it, and here you go. You can see 0 is not visible because it's on the 10, so it's going 1, 2, 3, 4, 5, 6, 7 till the end, which is 10. If I click it here, you can see we have a 0 and a 10. So that's the duplicate we have here, and we can delete the 10 to get rid of, it's like going to be 9, and then we can close the loft together, right? So we actually want to delete the 10 and then loft it. What we can do here is really simple. Reverse the list and say delete the last one, which is index 0, and then reverse it back so we have it in the same order, and then loft them together. Because if I don't give this loft option, which I'm going to explain, you can see that it's going to loft it, but it's not closing it. And because we have closed or open curves, if I, for example, make an arc and bring it a little bit up here, and let's make 2 curves, which these ones are open. Remember that they have to be open or closed. You can't give a mix of closed and open curves. Okay. Here we have to check out if it's closed or open. So what I have done here is that I've used the curve analyzes. You can see it here, closed, test if a curve is closed or periodic. So I'm going to give that to one of the curves, doesn't really matter. So remember that you have to be aware that you are giving either both of them are closed or both of them are open. And then you can see that it says, okay, it's is it periodic? It's false. And then we can use the surface loft option. And the option closed here will be false, which means it's going to be as the same of the surface here. Okay, let me just turn this on. Now that it's like closed or open, we can give it to the loft, and that's what I wanted to also explain, that be aware that you have to make it related to the curves. And here you can see when it's closed, it's automatically going to be, is it periodic? Yes. And it's going to close the loft and we will be okay. Okay, so that was the thing I wanted to explain. Okay, now that we have the loft, we can use that as the surface. So this algorithm is helpful to make a NURB surface from just 2 curves. And there's also a way that you can preview the UV curves on it. It's not really that important, but I think it's a good lesson. For this one, I've used again the curve spline isocurve, reparameterize it, and for the UV, I've made a multiplication to just have a good uniform preview of that. As you can see here, if I use the surface analyzes brep wireframe and give it a number slider, it's a little bit rectangular here, as you can see here, but in this way we're going to actually have some like how a square. So how can we do that? We can easily go to the surface analyzes and use the dimensions to get the UV dimensions. Then we can go to the math and divide them based on UV. What is the relative division of U and V? We get this number. So for example, U is 5 times the V. And then what we can do, as I explained, we can make a point, give it to the UV. Remember that this X is U, Y is V, and Z is not available. And then we can give range for both of them. And this time, when a U is this is a resolution thing, is like 3. It's going to, for the U, it's going to be 5 times, or is it 5 times, 6 times more than the V, right? And then we can give that a multiplication and to the N, and we will have that preview, which is actually somehow like a resolution thing. Just wanted to add this as a lesson, so maybe that's also useful in some of your projects. Remember that you can download these example files all from our website, parametrichouse.com, and remember to subscribe to our channel, like this video, share it with your friends, and let me know in the comments if any additional examples you need so we can record the tutorial. Thanks for watching. See you next time. Bye.